and Venn diagrams. Also the difference between or and and. So binomial probability, binomial, hopefully you can identify that means there are two outcomes. And the formula that we use is given by this. The probability that event E occurs X times is n choose X, where n is the total number of things there are, total number of trials. X is the number of successes. When we multiply that by the probability of X, or the probability of our event happening to the X power, because we'll have that many of these, and then the probability of failure, the probability of not E, raised to that power. These two exponents will always add up to n. So here's an example involving archery. 90% chance of hitting a target. Our event here is hitting the target. So what we're looking for is probability of at most 3 times. So that means the probability of 0, 1, 2, or 3 hits. Now this can be a little the probability of 4 or 5 hits. It's a much shorter calculation. So we're going to do 1 minus. So for 4 hits, that's going to be 5 choose 4. It's the number of ways we can arrange the hits in our order of 5. And then we're going to do 0.9, the probability of a success to the 4th, 4 hits, times 0.1, the probability of not hitting the target, to the 1st. And we're going to add on 5 choose 4, 5 choose 5, times 0.9 to the 4th, should be 0.9 to the 5th, 5 successes, 0 failures. And doing this calculation, we end up with 0.0815. Now, this is a calculator that we can, or a calculation that we can use our calculator for. And there's 2 commands in the graphing calculator that we're going to be concerned with. And the place we're going to find these things is under the distribution menu. Hit second, and then the variables key. And if we flip down to the bottom of this list, you see binom, PDF, CDF. The CDF is used for when we want, say, probability that X is less than or equal to some number. Binomial probability, PDF, is used when we want the probability that X is equal to some number. So what I could do here, I could select binomial CDF, and then I'm going to punch in 5, n is 5, there are 5 trials. Then I'm going to punch in 0.9, the probability of success, and then the number that I want to be less than or equal to. And there we are. If I wanted the probability that we hit exactly 3 times, for that what we're going to do is use the binomial PDF. Five trials, success is still 0.9, and I want exactly 3 successes, 0.0729. useful tool right here, but it is important to know how to do this without the aid of your graphing calculator. A box representing the entire sample space, U, and we have a circle representing A, event A. If we say n parentheses A, we're referring to the number of elements in A. If I throw in group B, A union B is defined as being the set of all x's where x is an element of A or x is an element of B. So A union B is everything up here. It's all of everything that's in the circles. That's A or B. A intersect B is defined as being the set of all x's where x is an element of A and x is an element of B. That is going to be just this part. That is the intersection of set A and set B. Here's a problem. We have a Venn diagram. I want to know the probability that somebody studies only one subject. Well, for this we need the total number of people. Probability is successes out of failures. So in this particular problem, there are 30 people total. Of those people, those 4 and these 2 only study one subject. These 15 study 1/5. Second question, find the probability that they study chemistry if we know they study physics. Another notation that we could use here, probability of B given we know that A already occurred. This is called a conditional probability. So we know that they study physics. So what that means is that this is the only thing that we really care about. We don't care about all of those people anymore. They don't count our sample set now. Well, that's 19. There's only 19 people that study physics. And of those 19, how many also study chem? That's just 15. So 15 out of 19 is pretty likely, I'd say, that if we know they study physics, they also study chemistry. Now we're going to verify that the complement of A union B is equal to the intersection of the complements of A and B separately. So A union B is everything in A and B. The complement of that would be everything that is not in these sets. So all that yellow stuff is the complement of it. Now A complement, if this left-hand circle is A complement is everything that's not in A. So that would be all that. B complement is everything that's not in B. So if we take B as being the right-hand circle, we're looking at that stuff. Now, where do those things intersect? This is the intersection symbol. Well, they intersect in all the space that's outside of these two circles, which is the identical shading that we used for the complement of A union B. So we've just done a mathematical proof using Venn diagrams.